Another question you might see in a standard international or national exam could look like this, could be something like this. Determine, look at this, determine the number of neutrons. I think this should be neutrons, okay, in the radioactive uranium, okay, in the radioactive uranium isotope, given as this, okay, given as this, given as this. Let's take it again. Determine the number of neutrons in the radioactive uranium isotope given as this. And you have options, right? Option A is 92, option B is 146, and then option C is 238, while option E is simply 119, okay? 119, okay? But it's very simple. It may look somehow difficult, but it's very simple if you understand what to do. What do you need to do? Quickly write a solution. But most times questions like this appear in the objective section of the question, where you are expected to choose any of the suitable or appropriate options, right? It could be A, it could be B, it could be C, it could be E. But if you know what to do, you just go ahead and do it. So let's see. If we are given the radioactive element is given as 2, 3, 8, all right? This is the element in question. And then atomic number 92. Mass number is 238. Atomic number is 92. So what do? Represent this the way it should be. This should be something like this, X, and this is Z, and this is A. No, the other way around. This should be A, all right, and this is Z, so to say. If you have this, we can pair them up. We can pair the two up. We now have here is 2, 3, 8, and this is 92, okay? If we compare, this is what? Z. Why am I writing Z? This is A, this is Z, okay? So if we do this, it means that A is equal to 238, while Z is equal to 92, which represent the atomic number, right? Okay, so we are looking for number of neutron, right? Neutron, look at it here, number of neutron. We can, for exam's sake, for solving sake, we can just use N to represent number of neutron, which is now A minus Z. Good. That's it. That is what I think it should be, and that is what it should be. All right, so we now maintain our solving N number of neutron is given as A, which is this 238 minus 92, which represents the atomic number of the radioactive uranium elements. Interesting, isn't it? And finally, what do we have here? We do simple subtraction, simple arithmetic here. So what we do is 238 minus 90. What do we have? This is 92, right? 92. Good. Oh, let's see. 8 minus 2 is 6, right? And then we have 13. This is 3. We borrow 1 from 2. Here it becomes 13. 13 minus 9, what will remain is 4. All right? And here, remember, we borrowed the 1 from this point, right? And what will remain here is just 1. We bring it down. Simple. That's it. That is it. Very simple. Therefore, we conclude by saying, therefore, N number of neutrons is equal to 146. Period. Solved. It's done. Look at this. Since it is an exam situation or exam question, we go back to the options given and then check if any of the options corresponds with our answer. That's it. And we check. Option A is 92, not it. Option B is 146. Of course, we have Number of neutrons is 146. Therefore, the appropriate, most suitable option for this question is option B. Okay? Option B. That's the answer. That is it. And you just take it and go your way. It's as simple as that. Thank you. See you in my next class. Come on.